Okay, first thing I want to say is watch your notation. You're being a little bit sloppy and it's making me nervous. So going down the tree, this branch is saying airbags deployed, this branch is saying airbags didn't deploy. Now here, this means the child was killed, but it's given that the airbag deployed. This one here would be that the given that the airbag deployed. That given notation is really important because it's therefore I think it may be your issue that you're having with problem number 2 because you're not using this notation, so you're not thinking fully through what it's saying to you. So nonetheless, the probability, this first branch is saying the probability of an airbag deploying is 29%, the probability of an airbag not deploying is 71%, and that matches what the problem is saying. Airbags deploy in 29% of all accidents, so therefore they don't deploy in 71% of all accidents. Perfect. Now, here's where students have some troubles here. They're saying, this sentence right here with the 31%. A child seated in the front seat who was wearing a seatbelt was 31% more likely to be killed in an accident if the car had an airbag that deployed than if it did not. So they're making a comparative. They're comparing two branches here. They're talking about the child that was killed where an airbag did deploy and where a child was killed where if it did not deploy. And they are saying the probability of a child dying or passing away in an accident where an airbag did deploy is 31% more likely than if it didn't deploy. So they're not giving us the actual percentage, they're just giving us a ratio. So this is where the fun begins. We don't know what this is, so we'll just call it X like we do in math, in always. So therefore, if somebody is 31% more likely, that's the 1.31. It's the simple idea of like 100% plus another 31%. You put those together, you put those together, that's going to make 131%. That written as a decimal is 1.31%. So therefore, if this branch is the X represents the likelihood of a child passing away when the airbag doesn't deploy, then this one is 1.31x. Whatever this number is, this one's 31% more likely because it has the original 100% plus another 31%. So now you will notice we have this branch filled in, we have this branch filled in, and for the problem they ask you, they say, what is the probability that an airbag deployed in an accident in which a child was killed? So therefore, for Bayes' theorem, we are saying the given condition is that the child was killed. It's either this branch or this branch. So therefore, we don't care. This branch here and this branch here might as well not even exist. We don't need them. Try to get rid of those. Your K's are there. There we go. All right. So therefore, when you write your Bayes' theorem, we have all the information we need, and you'll notice those variables of x will divide away, so your answer will just be a number. There will be no x's left over in them. So anyway, hope that helped.